Welcome, dear learners. Today I will start modelsing where I have left last day. Sharing the PPT. See, last day we have left discussing this IEEE library IEEE, where we will use library IEEE and how much it is beneficial, how much it is beneficial, and how logical functions will be written in this technique. I've also discussed data flow and somewhat I've touched behavioral. I've also discussed signal type, like how signals will be used. This will be discussed today. I will discuss decoder. Basically, a decoder. In case of decoder, we are taking out as not four variable. It will be taken as one variable with Q, or let it be O as a in-bit vector. So starting the same with model sim, I will touch VLSI, that is Jalings also. For implementation purpose, I will discuss. I will discuss Jalings too. So dear learners, you can see here decoder function. Here it is library IEEE, use IEEE.std underscore logic underscore 1164 dot all, a library you have to use. Then it is entity decoder 24 is. 24 basically it is 2 into 4 decoder. It's up to you. You can name anything here, but logic should be of decoder. Port it is AB in STD logic. It may be of vector type like A in STD vector 1 down to 0. It can be written like that also. Y is out STD logic vector, that is 3 down to 0, then N entity. This is architecture data flow of decoder 24 is. Then, since L is used for signaling purpose, L and M are used for signaling purpose. So we have taken this as LM. Basically, LM is used to have a negation of the input, that is A and B. That's why it has been used as intermediate. So it has been included in signals. Then Y0 is one minute. Just checking the recording. It's going on. Yes. So y0 is less than equal to L and M. Y1 is less than equal to L and B. Basically, if y0 is A complement B complement, y1 is A complement B, y2 is A B complement. So B complement place of B it is M, and y3 is A and B, and then is N architecture. Just checking the compiler. Yes, it is saying it is successful. Then simulating it. On simulation, where to just select decoder 24. So select decoder 24 here. Decoder 24 is here. Select decoder 24 and then N for wait for instant window. There decoder 24 is visible. Add it to the wave. All items in the region. See, at the same time, if we will do this thing, that add to wave all items in the design, all items in design, double time it has accepted, then I'm just deleted. Now see, all are uninitialized. Initially, if you are not using library IEEE, it will not show you. It is uninitialized. Basically, in IEEE logic, when you are using library of IEEE, that is basically there. It is defined that what type of signal it will be. Will it be low? Will it be high? Or is it initialized or not? That's why it is saying U triple or four times U. When you are not using library, it will show zero. All content will be zero here. So let let us take AB as A as 1 and B as 0. So since input is 1 0, so Y should be 0 0 1 0. Y should be, sorry, 0 1 0 0. It is first U is D3, then is D2, then is D1, then is D0. Since input is 1 0, so D2 will be active. Let us see. See, it is D3 is active. Since it is a array type, so you can click on this plus sign. On clicking on plus sign, you can see it is a bus type, and value of bus is shown as 1000. Here 3 is 0, 2 is 1, 1 is 0, and 0 is 0. Basically, y of 3 is 0, y of 2 is 1, y of 1 is 0, and y of 0 is 0. So in this way, you have to simulate a decoder. Now let A is in the clock form and see how decoder is performed. See, when A is 0, B is 0, then D0 is active. That is, D0 is active. Now again, when A is 1 and B is 0, A is 1 and B is 0, then see D2 is active. Again, when both are 0, A and B both are 0, then D0 is active. And we also know that decoder is basically binding to decimal converter. You can see input is 0 0, D0 is active. It is clarifying that yes, it is acting as binded to decimal converter. Like if input is 1 0, then output should be D2. See, D2 is active here. When input is 1 0, D2 is active. So it is verified by the simulation. Now suppose B is acting as clock here. Right now A is acting as clock. Let us take B as a clock, and its time period is 200, or let us take 50 picosecond. 50 picosecond, and then you are clicking it here. So here, after giving this frequency of this clock pulse, you can see here, just taking the zoom part here, using the zoom property here, you can see this part. When both are 1, 3 is active, that is D3 is active. When A is 1 and B is 0, see, it is D2 is active. When A is 0 and B is 1, then you can see it is 0 0 1 0, that is D1 is active. When both are 0, then output D0 is active. Means when at 0 0, output is D0, at 0 1, output is D1, at 1 0, output is D2, and at 1 1, output is D3. In this way, you can say it is proved that it is acting as binary to decimal converter. Now closing the simulation. Let us make some changes in programming. Since A and B are two different input, let us take it as a vector A in std logic underscore vector. Since it is 2:4 decoder, so I have to write it here. 1 down to 0. 1 down to 0 will keep the size of fix the size of this array. What should be the size of this array? So since it is 2:4 decoder, so its size should be of 2 bit. So here we're writing 1 down to 0. 1 down to 0. And in the signal part, here L is not A, not A. You should write it here, not A1, not A1. And here we should write not A of 0, not A of 0. Clear? Now LM is okay. L and B. It should be A of 0. A of 0. A2. It should be A1. Here it should be A1 and B of 0. A1 and B of 0. Then is AND architecture. Save it, and after saving, compile it. See, compiler is showing there are 3 errors. Let us see what are those. It is saying unidentified, that is B. Okay, so there must not be B. Here should be A0. Is there any B here? No, there is no B now. Save it and again compile it. See, decoder VHD is that is compiler has been successfully said that there is no error here. Now I'm simulating the same thing, and while you are compiling, you must see which function is selected. Which function is selected? This compiler is actually compiling that function which is selected here. Whatever in front of this screen doesn't matter, that that is going to compile. What is selected in this window, in the project window, that will be compiled. If you want to compile all the programs that are in this project part, all will be compiled simultaneously. If compile selected, it will be selectively compiled. Compile order. So these are the things here. Compile selected, and automatically if you are clicking this compile here, it is compiling the selected part one. So yes, successfully compiled. Then I'm simulating. See, either simulate from this part or simulate from this shortcut. At shortcut, you have to go through work, click on plus sign, then try to find this decoder 24. Try to find this decoder 24. Where is decoder 24? This is decoder 24. Okay. Then here, add wave, all items in the region. Again, see, there is L and M. Since L and M are intermediates, they are basically signals, you may remove these. So just delete. Now see, there are two. One is input, A is input, and Y is output. A is the area of size 2, and Y is the area of size 4. So automatically you can give input here. Let it be 1, 1. Now try to see the output. See, output is 1, 0, 0, 0. Here you can see D3 is active. D3 is active for the input 1, 1. 1, 1 is binary format, and this 3 is active means 3 is the conversion of 1, 1. So it is decimal, it is binary to decimal converter. In this way, this decoder is working. Similarly, let us take this as a clock force. Let it is 15 picosecond. You have to write PS here, else it will not take this as a clock pulse, else it will take this as a second. Maybe there may be some error there. PS, you have to match with this. You can also take microsecond, millisecond for proper visibility. Now see, let us use the zoom part. See this part. The upper part is showing the bus, that is decoder, a bus of 2-bit. This lower part Y is showing the bus of 4-bit. Bus of 4-bit. So see here it is Y is 0, 1, 0, 0. Then Y3 is 0, Y3 is 0, and Y2 is 1. Y2 is 1. Why? Since input is 1, 0. Input is 1, 0. For input 1, 0, Y2 is active. Then it is 0, 0. Input is 0, 0. In binary format, 0 is the input. Then output should be Y of 0. 0 should be active. That's why 0 is active. Similarly, here both input are 1. So input bus is 1, 1, 1, 1. Output bus is 1, 0, 0. 1 first, that is MSP is 1. That is D3, Y3 is 1. Y3 is 1. That's why output is 1, 0, 0. Similarly, you can see these outputs. It is repeating itself. I have taken A0 and A1 as a clock bus so that all the possible combinations can be viewed here. So closing this simulation, see within the same program, you can write other program also. Like suppose I want to run full adder program in the same sequence, that on the same simulation screen, full adder, output of full adder should be appear. So just taking the same here, let us see is there any error or not. Since full adder was selected, let us take this decoder. See, decoder is also successful. Means this is the program that is written on this screen. It has been successfully compiled. So multiple programs can be run on the same screen. However, doing simulation, you have to select which out of these programs you want to run. Out of these programs, you want to run which of these programs. There are two programs on the same screen. You have to select which program you want to. Both are compiled properly, but you can run one program at a time. If upper program is required here as a component, then no issue. But the main program which you want to run, that you have to select at the workforce. So considering the same thing, let us take one example where we want to draw. Just I'm taking one question here. See, there are three AND gates, and there are three AND gates, and all are of 3 bit. Three AND gate. This is three AND gate. This is three AND gate. Three AND gate means three input AND gate. And output of this AND gate is acting as output of this AND gate is acting as input to one OR gate. Output of this AND gate is acting as input here. Let us take this. This is OR gate. Now, suppose you want to have this circuit, how it will be done in VHDL. Similar circuit is repeating itself. Means same logic is repeated 3 times here. So here, it is logical here to write one time three input AND gate function, and then you have to call the same function 3 times. You have to call the same function 3 times, and that should output of these function, output of these gates should act as input to a 3 input OR gate. Since 3 input OR gate is used one time, so one time you have to program. The way you are calling the function in C programming or in MATLAB or in other high level language, in the same way technique is used here. The technique will be known as structural technique. Here one time you have to prepare the structure of any gate that is not in the library, since 2 input logical gates are defined in the IEEE library. However, three input, 4 input, these are not defined in the lab. So using the same example, let us see how you will prepare code for this requirement, the required circuit that has been taken. It has three input AND gate and one 3 input OR gate that is giving you output. Let Y is the output. So considering the same thing here, let us start with new program that is uh, 3-bit circuit required. I have programmed 3 input AND gate here. So taking copy of this, pasting this here, and library IEEE use IEEE STD logic 1164.all entity FA. Here I have to use some other name. Let the name is circuit CKT. Then is port map ABC. Let us take input, 3 input here. 3 input are 3 input here. Let us take here input are A, comma B, comma C. Let it be PQR. P, comma Q, comma R, L, M, N, X, Y, and then it's Z, X, Y, Z. Now these are the inputs here. So writing here, it is PQR LMN XYZ. L, comma M, comma N, P, comma Q, comma R, X, comma Y, comma Z. These are the in STD logic, and let Y is out. Y is out logic. 3-bit 3-bit AND gate is defined at first, and then we will use the same program. We will call the same program multiple times. 3 times we will call the same program here. So AND entity, then close it. After that, architecture with same name, that is CKT. Of CKT is, you have to take some signals also, since here you can see output of this first gate will be stored somewhere, output of second gate will be stored somewhere, output of third gate will be stored somewhere, and then these will be acting as input to one OR gate. So you have to store the output of these 3 input AND gate as some intermediates. Let us call those intermediates as A1, A2, A3, B1, B2, B3. Arbitrary, you can take any value there. So you have to take signal also. I will just write the signal as per the requirement here. Again, now after that, you have to use the above program as component using the same identity here. And 3 is, you have to write port map, you have to write the same port map, and then you have to write AND component. The function that is being called multiple time, that will be included as a component. However, in the same program, it is defined as identity. In the same program, its own program is defined in the same program. Its own program, component program is defined, its architecture is defined in the same program. You have to take care that it should be within that program, or if you are doing the work on this on just for system purpose, that program should be in the same project file, then only it will work. So since it has been taken as component, it will be used as a component. So I'm just replacing this entity part as component. Now I'm just writing the architecture. Begin. Let us take the architecture as structural. Begin, and then let us take some initialization, see how it is used. And underscore C port map is and underscore C port map is see in place of ABC, in place of ABC, you are using PQR. So let us take it as P comma Q comma R, and end of these PQR should be stored in some intermediates. Let that intermediate is A1. STD logic. You have to write it here STD logic. STD logic then is column. PQR, and this output of this PQR should be in A1. Then close it. You have to understand this, why I have written L1. Since multiple time you are calling this function, so to initialize the same function, you have to take some alphabet. You have to use some alphabet. Uh, at this position, you are calling this component. So you have to initialize this port map with L1. You can take B1, B2, B4. Then is L2 colon and 3 and underscore 3 port map is. Then you have to PQR, then is LMN. So write L comma M comma N and then A2. Then is L3 and underscore 3 port map each XYZ. So it is X comma Y, X comma Y comma Z into A2. Let it be A3. Since these three intermediates has been used, I have to include the same thing in signal portion. So A1 comma A2, they have the same nature. So taking them as STT logic, they're not vector here. It may be included as vector like A colon STT logic underscore vector. It has size 3, so 2 down to 0. It can be written as 2 down to 0. If you are taking this as a vector, let A1 STD underscore logic underscore vector 2 down to 0. Then here you will write A0, A of 1, A of 2. Now, what you have to do then, since A1, A2, A3 has been obtained, A1, A2, A3 is obtained, means this is A1, this is A2, this is A3. Now, these are to be odd. So, these are to be odd. So, let Y is the output, while less than equal to bracket A1 or A2, and then is or A3. Close it, and then end architecture, end architecture. See, is it working or not? There will be no is here. Let us save and compile. See, there is two error here. It is showing there is error in line number 16. In line number 16, there is error. It is saying it is should be LMN PQR XYZ. Okay. It is saying Y is already existing. Since okay, fine. See, in the component part, you have used Y. So you cannot use Y over here. Let it be Z here. So you have to take the output as Z. Now again saving it. Now let us see this error. It is saying Z is also existing. Where Z is existing? Z already exists in this region. Let us see where is it. Okay, Z is also here. Z is acting as input here also. So let it be Z1. And here it is Z1. Now, see, circuit required VHD was successful. So compiler has successfully compiled it. Now let us see the output. I think you can judge the output properly. Circuit name is CKT. It is using component of AND gate. So you need not to select AND underscore 3. You have to select circuit. Okay. And then see here, these are the input till Z input, and then Z1 is the output. A1, A2, A3. These are intermediates, so no need to see the intermediates. If though it will appear as its waveform will be visible, but it is nothing to do with input as well as output. So let us take this value till Z1 3 plus 3 XYZ plus 3. Z1 is output, so 6 input. It will be forced now. Let it be 1, 1. All are uninitialized. You have to initialize all the input. It is 0, 1. At least one AND gate should be 1, then only output will be 1. Now fine. See the out. Your Z1 is the output here. See, first 3 is giving you 0, next 3 is giving you 1, and last 3 is giving you 0. So, and all of these is output of these 3, output of middle continuous 3, continuous 1, and then is 0, 1, 0, end of these. So you can see among this only middle gate is giving you 1. So output is 1 here. Intermediates A1, A2, A3, it has nothing to do with the output as well as input. However, it is helping you to get the out. So this is the condition here. In this way, we have prepared this architecture, this required a gate using structural logic. You can take a snap of this through print scan. You can use these logics, zoom in, zoom out, then suppose bigger skin you want to sort it. Yes, it is possible using this logic. You can change frequency here, like pico nanosecond. You can keep it here. It will be accepted. You can reduce the size. So ending the simulation now. Now let us take example of encoder. Encoder is a circuit that converts decimal number to binary number. That converts decimal number to binary number. How you will design that circuit? For that, you have to name it encoder. Let us code for encoder. See, all are compiled. That's why this tick mark is here. We are using library, so library IEEE use library.IEEE entity decoder. So it is encoder. You should know the logic of encoder. What is the circuit? What is the architecture inside the encoder? That should be known with you. Whatever architecture you will feed here, simulation will be as per the logic provided by you. So suppose we want to design an encoder of 4:2 decoder of 4 input and 2 output. So 4 input, let us take A as input, as a vector input. So A in std underscore logic, it is a vector type of 4-bit underscore vector, and that should be 3 down to 0. Since it has 4 size of 4, so 3 down to 0 means 4-bit size, 3 down to 0. Then is colon here. Let B's output will be of 2-bit. Output will be of 2-bit. So let us take it as out std underscore logic vector, that is 1 down to 0. 1 down to 0. Then close it. Then add the entity and then write the architecture. Architecture data flow. Write the name here, that is encoder 42 data flow of encoder 42 is begin. Since there is requirement of some signal, let us take some signal here. Begin. See, when input is both 0, then output will be D0. Fine. When input is both 0, output should be D0. That's why B of 0 is less than equal to P0 see, suppose just discussing this part. Suppose input is it is D3, then is D2, then is D1, then is D0. Right? Suppose input is 1 0 0 0 0. Since at the input at decimal number is 3, output should be, what should be the output? Output should be it is Y0, Y0, Y0 and Y1. Y0 and Y1, Y0, Y1, and here if input is this, then output should be 1 and 1. Again, when input is 0, 1, 0, 0, 0 and 0, for this input, output will be 1, comma 0. So it will be 1, comma 0. Again, when input is 0 here, 0 here, and here is 1, and here is 0, then output will be, what will be the output? Output will be 0, comma 1. Now again, when input is 0, 0, 0, 1, that is D0 is active, input is 0, 0, then output will be 0, comma 0. Output is 0, comma 0. So you have to use this logic. Now try to think how you will design this. For that, you can see when y1 is 1, y1 is 1 for two position, that is D3 and D2. Either D3 is 1 or D2 is 1, y1 is 1. When y0 is 1, y0 is 1 for D3 combination and for D1 combination. Either D3 is 1 or D1 is 1, y0 is 1. Okay, so using the same logic, we will give logic for designing decoder, logic for designing encoder. So here you are using the same logic that I am discussed, just taking the same part here. See here, we are writing B, B1, let it be B1. A. So B1, B of 1, it is D, D of 3 or D of 2. Then is colon here, B of 0, it is less than equal to D of C1. B0 is 1 for D3 and D1. For D3 combination, when it is 1, 0, 0, see it is 1, 1. and V0 is 1 for 0 1. That is 0 1. 0 1 is active for green combination. Actually, green combination. That is this. For green combination, this 1 is active. So it is written as D3 and D1. D3 or D1. D3 or D of 1. Close it and then end architecture. Since we have not used any signal, so I am removing this signal part. There are no requirement of such signal. More the number of signals you are using, more LUTs you will be used. So if there is no need to use signal, avoid signal, else memory part is used much. When this will be critical when you are using, when you are implementing this on FPGA, much memory will be used if you are using more number of signals. So saving the same program, let us compile. See, compiler is showing some error. Let us remove it. It is showing library that is number 2. Architecture. Encoder, it is successfully compiled. Now let us simulate it. Four is to two input. Instant window, then air to wave all items in the region. D is acting as the input. It is of 4 size. It has B is acting as output of array size 2. D is array of size 4. Now let us activate third part. So forcing 3, I am feeding it as 1 0 0. See what is the output here. Output is 1 1. Yes, it is working. For 3, output input is 3 and binary format of 3 is 1 1. Yes, it is working. Now let us force it to 0 1 0 0. Now see what is the output here. Output is 2. 2 is the output here. 2 is the output. This is being shown as bus also. You can zoom in. For input 1 0 0, output is 3. For input is 0 1 0 0. Basically, you are activating 2 here. You are feeding 2 as an input. you are getting output 1 0. Similarly, suppose you are fitting 0 0 1 0. You are activating D1. You are activating D1. You are getting 0 1 here. See, for 3 it is 1 1, for 2 it is 1 0, for 1 it is 0 1, and for 0 it is 0 0. Here 1 doesn't mean it is not 0. Actually, you are activating 0 input, so you are getting output 0 0. So for today, this much. Tomorrow we will continue with our little bit combinational. Then we will start with sequential circuits. Thank you. Thank you so much.